Hi everyone, I'm Sai Kavya and I'm here with my team today to speak about our project, Adversarial Robust Deep Q Network for Algorithmic Trading. So let's go to the next slide. Uh, what are RL algorithms? Why are RL algorithms always trustworthy? So, how reliable are these algorithms in real world environments such as finance and algorithmic trading? And how critical is the assumption of perfect feedback in these practical scenarios? And what are the consequences of having blind faith in the correctness of the feedback? So, here's where reinforcement learning comes into the picture. So, the data source that we used is the Yahoo Finance data from 2018 to 2025, which contains the daily stock market data for equities, ETFs, and indexes. And the relevant features are open, high, low close, and adjusted close prices and the volatility. And we have also attached a link to the data set.
So for the algorithm trading environment, which we are going to use in DQN, we'll use this model as the macro decision process. So we're going to design the state using the lag return of length k. At each time, step k, we are going to use all the last k steps as our state. The action that is represents our agent can take are 0, 1, and -1. It means that you can take a long or short or stay neutral, but of only for a fixed magnitude. The rewards can be modeled using this model, which is the has the our impact factor without the true reward. So this is like the implementation of our baseline. So here we are using a DQN with the MLP and the CNN as the approximator for the Q table, and we can see that there is an increasing trend in the reward, which is shows that our agent is learning efficiently. So the key contribution of our work is that is the standard deep new network is robust against adversarial corruption. It is not. And is there a way to make you learning robust against such corruption? Yes, and we are going to propose in our project.
So I will take from here. First, I need to formally describe the adversarial corruption model. So for the adversarial corruption model, we assume that the adversary is pretty strong and it can corrupt up to epsilon t fraction of the first t corruption t iterations arbitrarily. And as we have seen we have actually managed to have a proper mathematical result which shows this effect that this adversary, even if it perturbs the whole system for a very small fraction of time, the things can be provably bad. So instead of going only with the mathematical result, we also have plots and other programming outputs to validate our claim. But we would like to take some time to appreciate this theorem, because this theorem provably says that adversarial impacts in the strong contamination model that we have discussed is actually uh, very crucial in determining the performance of deep Q learning network. So in the baseline, we have seen that we already have Rajesh covered the baseline part. We saw an increasing trend in the reward, and as we have seen, the adversarial impact has literally decreased the trend. So basically, the adversary is just flipping the reward in some sense. For example, if it is going to get three, if it was going to get three, we just proposed the adversary just proposed -3 in that sense. So basically, we see that even this attack, even for a very small fraction of time, can be catastrophic and things can be very bad. As we can see from the graph, it's down reading. So what we have proposed is like the deep Q learning network, the robust deep Q learning network is vulnerable to adversarial reward corruption, provably demonstrated, and also we have also the provably vulnerability of DQN. We have shown that how this DQN is affected by something for a very simple attack, which is called the Huber contamination attack. So we have two different kinds of attack model and two different kinds of result, which look similar but gives the similar guarantees, and all of them are provable mathematically. Lastly, I will discuss the results in a nutshell. So we have seen that when there is adversarial impact, the first two columns and the first row and the first two columns. So you'll see that there is a decreasing trend in the reward. The buy and hold trade just falls off. But what we did was like we use robust reward estimators for our deep Q learning network model, and we have already seen an increasing trend in the rewards, and the buy and hold trade stock are also increasing. So in a nutshell, what we can see is like we have I mean that we have shown in this project that adversarial impacts, no matter how small they are in number, can impact the deep Q learning approximation of finance problems severely. And in order to mitigate that, we came up with robust approaches to tackle the same. With this work, we propose, I think this can be significantly extended for a paper, and we are looking forward to work on that as a team. Thank you. The two major references have two of my papers, one published at CDC and one published at AIS Test 25. Thank you.
Thank you.